In the Venn diagram below, the universal set is a normal deck of 52 playing cards. The two sets shown represent clubs and picture cards. Picture cards are kings, queens and jacks. Show on the diagram the number of elements in each region. Well, in any pack of 52 playing cards we have 4 suits. We have 13 clubs, 13 spades, 13 diamonds and 13 hearts. So we 4 13s gives us 52 cards in total. So the total number of cards in this universal set is 52. I'll just write that in here in square brackets to indicate the number of elements inside this rectangle. The rectangle represents all 52 playing cards. Now, in each suit we have 3 picture cards. For example, for the clubs we have the king of clubs, the queen of clubs and the jack of clubs. The same is true for the spades. We have 3 picture cards. We have the king of spades, the queen of spades and the jack of spades. Similarly here, we have 3 picture cards, the king of diamonds, queen of diamonds and jack of diamonds. And same for the hearts, of course, we have the king of hearts, queen of hearts and jack of hearts. So we have 3 picture cards for each suit. So how many picture cards do we have in total in a pack of 52 playing cards? We have 3 plus 3 plus 3 plus 3. That's 4 threes, which is 12. So that's the total number of picture cards in a in a pack of 52 playing cards. We could write that out here. Just this 12 in square brackets outside this Venn diagram gives us the number of elements inside this Venn diagram. Inside the Venn diagram here means the picture cards. So there are 12 elements inside this set. And we know that there are 13 clubs, so I'll just fill that in. We're not required to fill it in, but it's helpful in answering the question, of course. Now, we have 3 regions to consider in here. The easiest thing to do is look at the intersection first of all. That is, look at the number of cards that are both clubs and picture cards. Well, I've that written down here. There are 3 picture cards amongst the clubs. The king, queen and jack of clubs. So once we've established that we have 3 here, it's quite easy to work this region out, because these numbers must add up to 13. So if this is 3, this must be 10. So there are 10 clubs that are not picture cards, namely the ace, 1, 2, 3, 4, 5, 6, 7, 8, 9 are 10 of clubs. Actually, I counted that wrong. The ace is number 1. Then we have the 2 of clubs, 3 of clubs, all the way up to the 10 of clubs. Okay, we have 12 picture cards in total. 3 of them are here, so 12 minus 3 must be here. 12 minus 3 is 9. Now, inside the universal set there are 4 regions. The 3 regions that I've filled in, and this region outside of these 2 ovals. 1, 2, 3, 4 regions. And the number of elements, the sum of the elements in the 4 regions must be 52. So we can work out the number of elements that are neither clubs nor picture cards by adding these 3 numbers together and subtracting the result from 52. So the number of elements that are neither clubs nor picture cards is 52 minus the sum of these 3 numbers. That all works out to 30. Now when I say elements here, the elements in this question are cards. Well, in general, we use the word element. So we have 30 here. A card is drawn from a pack of 52 cards. Find the probability that the card drawn is the king of clubs. Well, how many kings of clubs are there in a pack of 52 cards? Well, the answer is that there's one. That's it. Just one card, which is the king of clubs. And so that's the number of favourable outcomes. And we put that over the total number of outcomes, which is 52. So the answer is 1 over 52. A card is drawn from a pack of 52 cards. Find the probability that the card drawn is a club or a picture card. Now we're assuming that in these draws that each card has the same chance of being drawn as every other card. Okay, so we're dealing with a random selection. Anyway, here we want the card to be a club or a picture card. So how many clubs and picture cards are there in a pack of 52 playing cards? So we're selecting out of 52. Well, we can answer that from this Venn diagram. The total number of clubs or picture cards is 10 plus 3 plus 9. We had that already in the previous part. So we've 22 over 52. You can simplify down this if you like. Divide above and below by 2. Another way that we could arrive at this answer is to get the probability that a picture card, that a card drawn is a club, then get the probability that a card drawn is a picture card, then get the probability of the intersection. So we could use the letter C representing a club card, and we could use the letter P for picture card. So we want the probability of selecting a club or a picture card. Or in means the union of the two sets. The probability of event C or P means the probability of the union of these two events C and P. And we could use a big long formula for that. It's probability of C plus the probability of P minus the probability of C intersecting P. So basically that will give us those three numbers. The probability of C is the number of elements in C, number of cards in this set, over 52. So P of C is 13 over 52. Plus the probability of getting a picture card is the number of picture cards, which is 12 out of the total number of cards, which is 52. So 12 over 52 is the probability of drawing a picture card from 52 cards. And we have to subtract the probability of drawing a card that is both a club and a picture card. So the probability of selecting one of these three cards. These three cards will be the Jack, Queen and King of Clubs. So there are three picture cards that are clubs. And of course we get exactly the same as what we have here. Because we have 13 plus 12, but this was counted twice. So we're subtracting it here. 13 plus 12 is 25. 25 minus 3 is 22. So we still end up at 22 over 52, or 11 over 26. Okay, there's no real need to go into this formula. It's just much easier to refer to the Venn diagram and count up the cards, get the number of cards that are either clubs or picture cards. So there are 10 cards that are clubs. Actually, these 10 cards are clubs which are not picture cards. There are 3 cards which are both clubs and picture cards. That's allowed because the card can be a club or a picture card. And there are 9 cards that are picture cards but not clubs. That's allowed as well. So we just sum these numbers and put the result over 52. 2 cards are drawn from a pack of 52 cards. Find the probability that neither of them is a club or a picture card. Give your answer correct to 2 decimal places. Well, okay, let's consider the first draw. So in the first draw, we are drawing from 52 cards. And what we want to put on top of this fraction is the number of cards that are neither clubs nor picture cards. So we need to count up the number of cards that are neither clubs nor picture cards. Well, we can get that from our Venn diagram. We've already worked it out actually. We worked it out here. There are 30 cards that are neither clubs nor picture cards. I have it written down here, number of cards that are neither clubs nor picture cards is 30. So the probability that the first card drawn is neither a club nor a picture card is 30 over 52. Now we make a second draw. In the second draw, we will be drawing from 51 cards, presumably. Presumably when the first card was drawn, it was not replaced. So then we're drawing from 51 cards. So we are supposing that in the first draw, the card was neither a club nor a picture card. So that means that there are 29 cards left that are neither clubs nor picture cards. See, we're after drawing out a card that's neither a club nor a picture card. We've after drawing out one of these 30 cards. So there are 29 left. So the probability that the second draw is a card that is neither a club nor a picture card is the number of clubs or picture cards for the second draw, which is 29, that's 30 minus 1, over the total number of cards in the deck, which is 51. That's 52 minus 1 for the second draw. Now these are two independent events. So the probability that two cards are drawn are neither a club nor a picture card is obviously going to be smaller than the probability that one card drawn is neither a club nor a picture card. So to get a smaller probability, we multiply these two together. So multiplication makes sense here. If we were to add these two together, we would get a probability that is bigger than either of these two, and that would not make any sense. The probability of two cards being neither clubs nor picture cards must obviously be less than the probability that just one card is neither a club nor a picture card. To two decimal places, this probability is 0.33.